deep-water well can take years of planning and preparation. After identifying potential oil and natural gas reservoirs beneath the seafloor using seismic technology, a drill site is selected. Shell geoscientists choose the drill site location on the seafloor based upon the safest well path that will encounter the targeted oil and natural gas. For an exploratory well, in water depths up to 9,000 feet deep, this seafloor location is generally directly above the reservoir. A drilling rig is required to drill a well. In deep water, the rig may be on one of three vessels: a drill ship, a semi-submersible vessel, or it may be part of a floating production platform. All rigs have a hoisting system to raise and lower the drill pipe and tools needed to drill the well, a blowout preventer or BOP stack, and a pumping system to circulate fluids in and out of the well while drilling. It's time to drill the hole or well bore using a drill bit. This initial step is called spudding in the well. The shallow sediments just below the seafloor are often very soft and loose. To keep the well from caving in and carry the weight of the wellhead, a large diameter base pipe or casing is drilled or jetted into place. The base pipe is assembled at the rig floor, and a drill bit connected to a drill pipe is run through the inside to the bottom of the casing. The entire assembly is lowered to the seafloor by the rig hoist. At the seafloor, the driller spuds the assembly into the seafloor sediments, then turns on the pump. Water or a drill fluid is used to jet the pipe into place until the wellhead is just above the seafloor. With the base pipe and wellhead at the right depth, the driller will release the bit and drill string from the jet pipe and drill ahead. While the well bore is being drilled, mud is pumped from the surface down through the inside of the drill pipe. The mud passes through the jets in the drill bit and travels back to the seafloor through the space between the drill bit and the walls of the hole. Drilling mud is used to 1. Lift rock cuttings from the hole, 2. Keep the drill bit cool and lubricated, and 3. Fill the well bore with fluid to equalize pressure and prevent water or other fluids in underground formations from flowing into the well bore during drilling. The mud is an environmentally friendly water-based mixture of clay for thickness and fine ground rock or barite for weight. At the planned depth, the driller will stop drilling and pull the bit out of the hole. A smaller pipe or casing string is then screwed together, connected to the drill pipe, and run down to the seafloor and into the well. To permanently secure the casing in place, cement, followed by mud, is then pumped down the inside of the drill pipe. To separate the cement from the mud, a cementing plug is used. The plug is pushed by the mud to ensure the cement is placed outside of the casing, filling the annular space between the casing and the open hole wall. On some locations, a second surface casing is needed, thus the well is drilled even deeper. In this second surface casing interval, the well is cemented using a second smaller casing string, repeating the same process used in the last hole section. At this point in the well, the pressure in the deeper rock may be too high to continue with the simple water-based clay mud, or there may be the potential to encounter oil or gas. Before drilling below this point, a blowout preventer with a riser will be installed at the sea floor. The BOP stack is a massive system of valves and rams that protect the rig and environment from oil and gas flows should the weight of the drilling mud be too low. The BOP stack is connected to a pipe called a riser. The riser connects the rig to the well and allows us to circulate the drilling fluid and rock cuttings all the way back to the rig on the surface. The BOP stack is fully tested before we drill further. Drilling now resumes with the drill bit and drill pipe always operating through the BOP stack. Just as we did further up the hole, casing strings are run and cemented in place when needed to cover up the open hole sections. When the oil and gas zones targeted by the geologists are reached and the presence of an oil or gas zone is proven, a final casing string may be installed if the seafloor location is favorable for future development. This final casing string allows for the future safe production of the oil and natural